Good morning. I just want to show you something I'm doing out here. If it might help you a little bit on how I set up the plasma for an easy cut. I've got a welder that wanted me to make him 50 plates for a welding job that I don't know a lot about, but I'll show you how I do it. Cut 2D works great for plasma stuff. It's the best software for someone that like me that's not great at CAD work. So I just opened it up. This program, once you buy it, you own it. You don't have to subscribe or do anything. They send you updates all the time. So let's just go in here and create a new file. Okay. Ask you what work size, job size you want. Well, a lot of times if you're drawing something, just go ahead and put the size of your 4x8 plate or whatever it is that you use on your table most times. So width at 96, height at 48, depending on how your table's laid out. That's how my TrueCut table lays out right there. And push OK. Okay, we're set at 0, 0 on the lower left corner. That's where I work from. All right. Now, what are we going to do? Well, what he told me is in a text message is he needs uh, about 4¼ inch squares with 4 holes in the corners, and he's going to put weld a 3-inch square tube in the middle. That's really all I have. So let's go over where it says create vectors and just hit square. And let's put in the dimensions we want here, which I'm going to select this lower left corner here though on the anchor point on this. Square, nothing, no radius to externals. You can radius the corners if you want here, but no, we just want square corners. So let's put in 4. I'm going to give them a little extra. I've already messed with this a little bit. Let's go 4.3 inches instead of 4¼ inches. Okay, 4.3 inches gives a little more room for the holes. And see, I didn't do that right. So push Control Z to get rid of something. See the X and Y? That should be on 0. So let's put a 0 and a 0. That'll put us down here in the lower left corner right there. Or you can just click it there if you want. Wherever you want to put it, you can just click it. But put the coordinates there, create. Okay, let's close that tool out. Although we know we need a 3-inch in the middle just to look at, so let's go ahead and put another square. And let's anchor that in the center. Let's put 3-inch and 3-inch. And if you'll notice, if you move over this stuff, it pops up, it's snapping to that center. I'll say it is. See that right there? See a little dot showing up. You might not see it good, but it's a little dot showing up. Just click that, and that centered that. And there's the math on it. 2.15 is the distance from center to there of a 4.3-inch square. You could do the math and just put it in there if you want, whatever. Close that tool out, just click off so it's not selecting anything. So if we want a hole in each corner, you could do the math and figure out a hole pattern, whatever. It's easy enough to just, I've already did the math on this of where I want the hole. So let's just go to circle. We want the diameter 415 thousandths because that gives me 40 thousandths extra for a 3/8 hole. I've already cut some holes, and that's what it takes to slip a 3/8 bolt through that hole on the plasma. And I want to put those at 359 thousandths from the center of the hole to the edge of the material, both the X and the Y. Okay, that's in there because I've already done that once, so you can put any numbers you want, but 359, let's just push create. And there it is. Now we can look at that up close and see how much room do we have around that hole. So let's measure. Oh, sorry, I went a little fast. See these different ways these are laid out with where you create the vectors. Transform is to move things around, and edit, it has the measuring tool right there. You hover over these, you can see what they do. See measure. So measure between 2 points. That's what I want to do. You can also like measure angles or different things. That's the most common right there, is just the distance between here and there. It kind of snaps to the center line of that, so let's just click that, left click it, get to, it's not really snapping that edge very well, but you can, on the bottom down here, you see it shows your coordinates down here where your cursor is. If you're worried about it too much, zoom in, and the more you're zoomed in, the more control you have with how much you move it. That's real close to that, so let's click that. That gives us, see up here, it shows 151 thousandths. That's a little over 1/8 of an inch. And that's really all we can do. And from this area to the circle is 200 thousandths, so it's a little over 3/16 of an inch. So that's good enough. I've already asked him. You can right click to get out of that tool, or just click off of it, whatever. So that'll work just fine right there. So let's do 4 of those. The easiest way I know of to do that, and again, I'm not an expert at CAD, that's just how I do things, and it works just fine. So just draw a box around to select the whole thing. And let's go right here where it says transform. If you hover over it, says rotate objects. Let's push rotate. And you see that mark in the middle? That's what it's going to rotate around. You can change. See, if you did that, it would rotate them down here, but we want to rotate off the center. And let's put the angle we want to rotate it. Do we want to go 45 degrees, 90 degrees, 180, whatever? Let's go 90 degrees. Push apply, and see, it just rotated it. So let's close this tool, click off of it. Let's draw another circle with the same stuff. That's, see, it's already saved what we did last, so let's just create another one just like that. Close it. Again, select it all, go back to your rotate tool, and let's put 90 degrees in again, apply, and close the tool out. Go back over here to circle, and let's create another one. Close the tool. I know this probably seems like a long way around for some people, but go back into our rotate, put 90 degrees again, apply, close that tool, go back to a circle, and create it again. Every one of those now are exactly where the first one was, what we want. Pretty simple, right? And that's, I've already did a test cut. I like it the way it cuts. Now, we don't want this in the middle, or we'll end up cutting a hole out in the middle of our plate. So just click that and either hit delete, or if you want to, you can right click and find delete, whatever. So that's our file ready to save. We can check our file by selecting it all. If you want to push this vector validator, it'll show errors right there. If you push search selected, it'll come up and show a bunch of errors if you had any. I don't see any. Or while it's selected, push the N for node editing, or right click the screen and look down here. It says node edit mode. It shows you the shape. If you had issues, somebody sends you another drawing, a lot of times it's a DXF or something, a lot of times you'll find errors in your file. You'll see them real good in your nodes. You don't want a bunch of nodes in here, or a bunch of lines that look like they're all broken or something. So just push in to get that tool back off, click off of it. I like to save everything right here in the 0, 0 corner. That way when I go in, it's not way off the screen somewhere. It's just, everything's always easier if you save everything just like that. If you had other drawings on the screen that you don't want to save, you could always just select this and then save it. If nothing else is on the screen that you don't want to save, just leave it alone and go up here to File, Export. I like to use SVGs. They seem to be a cleaner file. If and SheetCam will use SVG, so I recommend always saving it as SVG. And I go in here. This is where I saved to OneDrive. That way I can pull these files out there at the machine if I want. I have all this same software out there, but I saved it right here earlier on this test file, so let's just save it there. It says it already exists. Do you want to replace it? Yeah, I do this time. Okay, that's it. We don't need this open. it's going to say, you want to save this? No, I don't want to save anything. All it's going to do is save it as a CAD file. I don't need a CAD file. I just wanted that SVG file. Say no. Now let's open SheetCam. We have our drawing, but we don't have our cut paths yet, right? So it's trying to do an update. I'm not ready to study that yet. So let's, this is already set up for the size of my sheet. In this case, I'm using a bunch of little pieces. So it's going to be a little more complicated. So that's why I'm only doing one. When I told you I need 50, well, I don't have a full sheet. I'm using a bunch of scrap pieces. So let's just go in here, and I've already done this. I'm just going to show you real quick how I do this. So go in here to File, Import Drawing. That's the file selected that we want. Let's just open it. Scaling it 1:1, yes. If you want to go up, if you want to make something bigger or smaller, you could always change that scale on something and change the size, but I prefer going to drawing and change it personally. But anyway, you can do that. Push OK, and there's our drawing. Okay. Holes, you want to slow holes down. Cut them at about half the speed you cut everything else. So we're cutting 1/4 inch plate here. Let's go up here to where it says Edit Contours, where that C is. Just click that. If you click anywhere on this screen, don't click on that because it makes it goofy. You could do one at a time if you want, or if you want, just click over here, right click right there. See where it says Select All Holes? Just go from all layers. We only have one layer at this point. Okay, so now get on one of them that you just selected. Just right click on one of the holes and say Move to Layer. And it's going to say New Layer. Now it's going to let you name that. So let's name it Holes. Okay. And let's go OK. Let's check that now to make sure we really did do that. See over here where your layers are, just unselect holes and see if they go off. Yep, they went away. If you'll notice, if you push the other layer, the square will go off. Now let's say if we wanted to make a bunch of plates with holes and then a bunch of plates without holes, well, you could use this same drawing and just turn that feature off and then don't cut the holes, right? That's a pretty good way of doing that with the same drawing. Or you could go back in the drawing and delete them and save it as a different file. Just whatever you want to do there. So now go down here where it says Operations. We want to do an inside offset. That's because we want to cut the holes first. Those are on what layer? Let's see, they were in the holes layer. We're doing this tool here, so you can select whatever you're doing here. But we are on 45 amp, 1/4 inch steel. That's the tool we want. It saved it from before, that's why it's in there. On a hole, you want to select this perpendicular cut of about half the distance of the hole, roughly. You want to pierce in about the middle of the hole, so it's going to be about a 0.2. And coming out, you can use a arc lead out on the hole. Let's do a little less than that, say 0.1, about 100 thousandths lead out. There's going to be no material left in there anyway, so she's kind of leading out away from it. So, and then just push OK. Now you can look and say, do I like how that is? Yeah, it's going to pierce right here. It's going to come in. You always want to go counterclockwise on your inside cuts, and then it's going to lead out like that. Okay, that's going to be the fourth cut. It's going to start on this one right here. S1 is your first S1. Come over here to S2, S3, and then S4. And that's all of our holes. Now remember I said we want to cut those at half the speed of what we're cutting 1/4 inch at. So let's go over here to the V, set a variable. It's set at 100%. Let's go down to 50%. Now whatever your machine out there is set at, this will automatically, Mach 4 that I use out there pulls in the file. With the tool that we put, it's going to set it at however you have Mach 4 set at about 40 to 45, somewhere around in there. We want half of that. So let's put this variable, now it's down here. We want to drag that variable above. This is the order it's going to do the operation. So we're going to set it at 50%. That's going to cut the holes. Okay. Now we still got to cut the outside. So let's do another operation here. And let's change that to an outside offset. It's not on the whole layer now. It's on that one that's called color 0 up here. Still the same 45 amp, quarter inch. We're going to change this to a tangent lead. Works a lot cleaner. Let's go with about a 0.3 length lead in and probably about 0.2 lead out. It's whatever you want there. Tangent and tangent. I'll show you what that does. A real clean cut on square corners. And that's it. Let's push OK. I don't like the lead down here kind of off material like that. So if you want to move that lead around, I want it right there is really where I want it, because see, it's like potentially going off material everywhere else. Because I like to line my torch up where I feel comfortable on the left side and then down here. And I don't want to worry about the lead interfering with that. It'll be kind of lead in off material. That ain't no good. So go up here where it says S, edit start points. But you have to select this down here, the operation we're dealing with, and see how it's just chasing you around. You can put that anywhere you want it, but remember I want it right there. So just click that, left click the mouse right there. Now there's one more thing. See, we had that feed rate at 50%. It's still going to be at 50%. Anytime you change a G-code, it keeps it that way until you change it. Okay, so let's put another variable in there, and let's turn that back to 100%. Okay, it's down here. We need it above where we want to use it. So there we go. We're going to be at 50% and cut the holes, and then we're going to be at 100% and cut the square. Okay, that's really all there is except saving the code. Now, I just want to remind you though, if you change the variable below 100%, at least the way my machine works, let me turn this back to selector so it ain't doing that. You won't have, torch height control will turn off. If you change a variable less than 100% feed rate, then it turns torch height control off. That's just fine on a hole, because all you're doing is you're sitting down on a hole and you're cutting a hole. It don't need to go a long ways and with varying height of material or anything. It don't need that, and it just turns it off. That's why you just need to remember that. If you worry about that, sometimes that may affect you if you had a big hole or something and you want to turn the variable down. Anytime you turn it down that way, it will turn your torch height control off. Just be aware of that. So we're done with that, except let's go up here and push the P. That's run post processor, and it's going to save that to whatever you name that file right here. And I save that in on OneDrive again because I can pull that in the shop. Just push save, and it says it's in. Yeah, I know it's in there. Okay. And there's our G-code. Now, if you want to look at that and see where that did that change, like I told you, see that B50? This is our pierce points. If you'll notice, it's going layer is holes, pierce number 1, and then it goes B50. That means 50% feed rate right there. C1. Okay. If you'll notice, there's 4 times of that. There's our second one, third one, and the fourth one. That's the 4 holes. And then it's going to do the other one, which is just layer color 0, pierce 1. You'll notice that B is back to B100. That's 100% feed rate. And also you'll notice after this it says M1101. That means it turns your torch height control on right there. Because if you'll notice up here, after the C1 down here, there wasn't anything there that said M1101. So it didn't turn torch height control on. That's what that's going to be right there. And not that I'm that great at understanding G-code exactly. I mean, I do understand a lot of it, but you can look at that and compare things and figure out which one of those is doing something like that, because you know, down at the bottom of that code you could see that M1109 is, or 1105, I don't know which. One or the other of them is turning torch height control back off in the code, and M30 just resets it back to the first of the program, so you can do another cut or whatever. So anyway, so I just close this. When you push close, it's just going to say, do you want to save your changes? Well, I already did. If you save this, it's going to save a job file. You can come back, and since I'm just using little remnants right now, I'm going to do this as one, and I may come back in if I find a certain size material. And I can, once you have your toolpath, you can array a whole bunch of these on the screen in different patterns. You do that through this nesting up here, and you can put more of them on here. And I'll probably do that later, but that's not what this is about. So anyway, let's say no, and that's closed. And so let's just go out in the shop and work on these cuts. Alrighty.